Good morning. My name is Annabel Abu Hanna, and today I will be discussing the very interesting topic in the field of material science, which is 3D printing of concrete. Okay, let's start off with defining the material in use, which is concrete. Now the basic composition of concrete is sand, cement, and water. However, sometimes broken stone or gravel are added into it. This mixture is poured into molds. These molds are usually made up of wood or metal. And upon hardening, it forms a mass resembling stone. There are a couple of benefits of concrete houses. First and foremost is that the reduced cost of a typical house, and how energy efficient it is when we talk about heat transfer through and out of this material. And third is how safe it is when it comes to the strength of the material withstanding natural disasters. And fourth and most importantly is how durable it is. Now the first house, as we can see on the right, was made by Thomas Edison in 1899, and on the picture above we can see that this house is still standing until this day, although it was created in 1899. Now moving on to the chemical properties of concrete. There are 6 main chemical properties that we should discuss. The first one being the fineness. Now fineness is actually related to the particle size. The smaller the particle size, the higher the fineness, and it is directly proportional to the hydration rate. The second property is the soundness. Now soundness is the ability of cement or any material to not shrink upon hardening. Actually, soundness might appear in later years, so tests like Le Chatelier and autoclave are made to predict such failures and to prevent them ahead of time. Now the third property is the consistency, which is the ability of cement paste to flow through the mold. The fourth property is strength. Now strength is actually affected by various factors, including water-cement ratio, curing condition, size and shape of a specimen, loading condition and age, and lastly the manner of molding and mixing. Now as presented in the slide, there are 3 types of strength. The first one being compressive, and then tensile and flexural. Now the most important test, the compressive strength test, is actually the most common and most important test because it shows us specific characteristics and properties of the concrete. As for the tensile strength, it was before it was actually used a lot. However, now it does not give us accurate representation of the properties. As for the third type of strength, the flexural, it is just like the tensile strength. However, it is the tensile strength in bending. As for the fifth chemical property, it's the settling time. Now cement sets and hardens when water is added. It varies with multiple factors, of course, such as fineness, cement-water ratio, and chemical content. However, the general rule of thumb is that cement should have an initial settling time that is not too low, typically between 30 to 45 minutes, and the final settling time that is not too high, typically below 10 hours. The last chemical property to be discussed today is the heat of hydration. Hydration is the reaction that occurs between cement and water. It usually generates heat. Now this heat can actually be used to better the quality of cement and to maintain the curing temperature in cold weathers. However, if it's too high, if this heat generated is too high, it can cause undesired stress in large structures. Since we have fully understood the material we're using, now we need to understand the process we're using or the method we're using, which is 3D printing. Now, the 3D printing process builds a 3-dimensional object from a computer-aided design model, usually by successively adding material layer by layer, and so it's called additive manufacturing. Since 3D printing is used in many fields nowadays, it might seem as if we are using it in concrete just to keep up with technological advances. However, this is not the case at all. There is a huge dilemma that we are facing in building concrete, which is the expensive framework. Let's think about it for a second. To build a reinforced concrete structure, we need to first build the wood structure, which is the mold, and then add the cement and steel structure into this wood structure, and after it has been cured and settled and hardened, we then remove the wood structure, and then we have to repeat this process over and over and over again for every structure. This is not very convenient when it comes to the fact that I am building two structures to, in the end, have one structure and one disregarded. Not to mention the fact that there is excess waste of the extra concrete and the disregarded framework that we can only reuse 5 times and then disregard. Now, a very important question to be asked is that, is normal molded concrete made up of the same composition as 3D printed concrete? Now, here's the answer. 3D printed concrete actually differs compositionally in 3 ways. In addition to the basic ingredients, which are cement, sand or aggregate, and water, we also have a reinforcing ingredient like carbon fiber, and an adhesive ingredient like water putty, and a hydrator like sodium silicate. This produces a very different concrete, one that can maintain its shape when it's wet. It's also a very rapid hardening material with high strength capabilities. There are multiple requirements for successful 3D printing of concrete. The first one being the pumpability. The material has to be fluid enough so it can be pumped to the point of placing. A second being the extrudability, as the material should hold shape after being forced out of the nozzle. The third being the buildability of the material, since a particular layer of concrete should hold the weight of the additional layers that will come on top. The fourth being the repeatability. The process should of course be stable and repeatable in the same testing conditions. The figure below offers examples of the component types, print orientations, and geometrical features that have been demonstrated and can be classified into 3 application families, from A to F. The first one being the components that either stand alone, such as C, or are forced assembly, such as D and E. There are other types of components, such as walls and columns, that are printed, such as F. And the permanent shuttering, where the shutter is printed and the structural element is cast conventionally, such as E and B.
Here we have the world's first 3D printed mansion. It's 3 floors high, and from this angle, it's kind of difficult to see that it's 3D printed because of the finishing on the exterior. But if you come with me to this side, you can see, like with all 3D printed buildings, it does have the layering structure on the sidewalls here. Now let's take a look inside. The inside of this building is very well fit for any homeowner. You have a 2-car garage. And then a small first floor washroom with a large dining area on the side here. Now in this dining area, you can see that these tables have been 3D printed with just a piece of glass on top.
This previous video shows us and presents to us the latest advancements in 3D printing of concrete. Now, although this technology has started in the early 2000s, however, year by year we see advancements in many aspects of this 3D printing of concrete, including the creativity of the designs and of models, and of the finishing precision, and the shape and the size, of course, of the model built or printed. Now, as we can see in the last part of the video, that they have not only used 3D printing in the building or in the construction of the house itself or the building itself, they have also used it in the furniture, as he showed us with the tables that were 3D printed. Now, a very important aspect of 3D printing of concrete is that we can cut costs on construction and spend more money on material and design to give us a better model in the end. I personally felt like this video and the video before would best describe the development of concrete 3D printing, since the video before mentions that it's the largest 3D printed concrete model. However, this video also says that it's the largest 3D printed concrete. Keeping in mind that the date of release of this video was in 2018 and the previous video was released in 2019, shows us that from 2 stories high to 3 stories high was actually an advancement that was made throughout 1 year. This really highlights that 3D printing of concrete is really advancing year by year and is taking huge steps forward in such little time. Of course, this video has just presented to us the process of 3D printing. Before this part of the process, there is the process of mixing the ingredients together, which are as I mentioned before, the reinforcing ingredient, the adhesive ingredient, the hydrator, and of course the cement, sand, and water all together. And then the 3D are then fed into the 3D printer. The 3D printer, of course, takes the commands from the computer-aided design that the human has designed for the 3D printer to print. And then it follows the method of layer by layer to, in the end, produce the model that you have designed through the computer and given it the commands and the codes to do so. Now, there are many advantages in concrete 3D printing that keep scientists and researchers holding on to this field and really pursuing it and advancing it. The first one being minimizing construction waste, because we don't need any framework, as the 3D printed model is not put into any mold. It is printed directly, layer by layer over the other. Now, minimizing production time is also a great advantage, as the machines and the printing models and the printing machines, they can work 24/7, unlike a human would. Which brings me to the next point, which is reducing labor costs. The only cost you're gonna pay is the cost of the printing machine itself. Now, a fourth advantage is pushing the realms of design, as you can really put out your creativity into a model design that would later be printed into the concrete model that you want, with as many designs as you can possibly think of. Now, of course, there are also disadvantages of concrete 3D printing. Such as, for example, very small margin in error, since it hardens quickly, and if you make a mistake in the print, you will have to disregard it a whole and start again. The second being the that we are limited with size of the printer, and so limited with the size of the object printed. Of course, the printer itself has a very high cost. However, all of these disadvantages are expected with a new technology. Now, the cost of the printer with time and supply, of course, will go down in the future. To conclude, all of these disadvantages are nothing compared to the advantages of such a science and such a field. There is a tremendous future potential of concrete 3D printing. And as I said before, the new technology costs will decrease with time, and so this potential will keep on increasing until we use it to the fullest. After having concluded, I have come to the end of my presentation. Thank you so much for listening, and here are a list of references that were very beneficial for me and very informative. Thank you.